My name is Lisa.
And I'm Chris.
And today we're going to talk about viscosity and what it is. What is viscosity, Chris?
That's a very good question, Lisa. Viscosity is an important fluid property that all fluids have. It characterizes resistance to flow, meaning that a fluid with high viscosity will resist flow more. An example of this would be syrup, which has a high viscosity and is going to flow more slowly than a low viscosity fluid such as water.
Very true. So we've got three liquids. We have water, honey, and molasses. So this is a viscometer, and it's a cylindrical cup. And on the bottom there's a hole, and we're going to put the viscometer into each fluid, and it fills up to the top of the liquid goes into the top of the viscometer, and then we will lift it no more than 6 inches, and then we're going to time how long it takes from the liquid to break, and that will determine the viscosity of the fluid. So we're going to measure water, the time of water. So Chris, are you ready?
I'm ready.
All right, get set, go. So water flows really fast, and it stops now. So it breaks now. So it only took about 5.9 seconds for water to flow through the viscometer. We're going to try molasses. And molasses is a little different. It's extremely viscous, which means that it's got a higher viscosity than water. Water has a very low viscosity. It's not resistant to flow. This is way more resistant to flow, which also means it will take longer in time. Okay, so I'm going to lift this up. Are we ready to time how long this takes?
I'm ready, yep.
All right, Chris, get set, go. As you can see, this is going to take probably 10 minutes because we had tried this before earlier. So this doesn't take 10 seconds, it takes about 10 minutes before the molasses will drip out of this. I guess at the same time we're also going to measure honey. So we're going to time honey. So honey is also extremely viscous. As you can see from the fluid and the liquid that it doesn't flow very easy.
Do you guys think it's going to take longer or shorter for the honey to flow through than the molasses?
And we will find out at the end of this experiment. We're going to start filming honey now. Ready, set, go.
You can also see it's very slow. You can't quite tell if it's faster or slower than molasses. Any moment now.
Oh, there it is.
Nope. Snap.
This is the inner cylinder, and this is the outside cylinder, and we filled the entire of the inside with corn syrup. Corn syrup has a really high viscosity. What we're going to do is rotate the inner cylinder and see what happens to the dye that the food dye that we've inserted. What we should see is that the inner die will move further along than the outer die. So the reason this works is that when we try to rotate the inner cylinder, the corn syrup will resist the movement. And the further away from the circle, the inside, the more it will resist. That's why the inside die will move further than the inner die. So what do you think will happen if we rotate the inner cylinder back to where we started? As you can see, the dies returned roughly to where they started, because the same amount of work, the fluid resists the same way when we reverse the turnings. And this works because this fluid has a very high viscosity and it resists the flow.